Hello everyone, this is Mark Van de Wettering of the Brainwagon blog, playing with a plastic dinosaur. No, not really playing with a plastic dinosaur. I've got a breadboard out today and I've thrown together a little oscillator and divider circuit, and I learned something that every engineer in the universe seems to know except me, but it's the first time I even knew it, but it's the first time I've seen it demonstrated in such a dramatic fashion. I'll ignore the circuit for now. You can look at my blog post if you want to read up on it. But here's the square wave that's coming off this thing. Remember, this is a little counter chip, and let's see if I can zoom in here a little bit better. You can see that it's pretty ratty. The top of this signal is bouncing around by, several tens of millivolts probably. The undershoot and overshoot here are probably more an artifact of my scope, but what's this all about? Well, I assembled this the other day and I go, God, what is going on here? And then I realized that unlike what you're supposed to do, I didn't install any decoupling capacitors. So let's see if I can do that here. We'll just jump her in a little cap, and you can see, voila! There's still a tiny bit of ripple, but it's much improved, much less noisy. This is just 0.1 microfarads tied with probably too long of a lead between the power supply for the chip and the ground. And you can see that that actually smooths it out a lot. Now, before I didn't really understand why this is needed or why this works. And basically, as the chip oscillates, it uses different amounts of power, and the power supply itself can't adapt to the changes in current, or, well, I think that's roughly true. Basically, the power supply can't react to supply the current necessary to keep the voltage steady, and so you get voltage wavering a little bit. And when you install the cap, basically the cap just serves as a really high frequency, well, reasonably high frequency source of energy for the circuit to use, so that it can take some of the charge from the capacitor and use it to supply the chip, and that will help keep the voltage stable, and that's what it does. So what's this circuit all about? Well, let's go back over here for a second. You can't really tell here. Let's see if I can get a little tiny bit more light on here. Well, not much more light. Excuse me for the impromptu-ness of this. Yeah, it's not going to help any. This chip here is a 74HC4060, and there is a crystal of some dubious value. I have no idea what it is. I just was using any crystal that I had. The idea is basically this crystal gets divided through by this counter, and you can get different versions of the, depending on which output pin you tap, you get different divisions of the original crystal frequency, divide by 2, 4, 8, all the way up to 14 bits of division. And so, one square wave could look like this, but if I look at the next pin over, I'm not changing the oscilloscope now, then this is lower frequency. Well, now I have to drop the frequency, so let's try this. So let's go, so here's the original one, which is really fine. You may not even be able to see those. And then so you can divide by 2, or 4, 8, or you can get all these, oops. So you can get different divisions of this thing, and I'm just sort of poking things at random. So you can get fairly slow ones. This is now doing 1 millisecond per division, so these are about half a millisecond pulses, and you can get all sorts of different widths of these. So I've been interested in low frequency radio for quite a while. This is actually the exciter for a part 15 low frequency radio that would operate between nominally 160 and 190 kilohertz. If this were a 6 megahertz crystal, I could divide that by 32, and that would be 187 kilohertz, which would be just about right for experimenting with low power beacon operations. So that's what this is about. But really, the lesson learned today is, wow, decoupling capacitors actually produce a visible effect that you can actually see with even my crummy $20 oscilloscope. So that's pretty much it for today. I hope that you enjoyed this. If you'd like to see more of this kind of stuff, give me some feedback on the YouTube page or on my blog, and I hope you're having a good day. This has been Mark Van de Wettering of the Brainwagon blog. 73s, and have a good night.